Canada Architects, and today I'm going to talk about BIM delivery. Before I go on, I got to plug CH2M Hill because I get asked at every single conference, every single presentation, what does that actually mean and why is it called CH2M Hill? So it was started by the five founding fathers of the firm who were based in Portland, Oregon, and went to school in Corvallis, which is Oregon State University. And I believe it was Merrifield who was the professor, and the first three were students. They formed a firm and then merged with Hill. And that's how you get CH2M Hill. And we have about 26,000 worldwide. In our Toronto office, we're about 400. The architectural portion of the Toronto office, there's about 15 of us, 4 licensed architects, and the rest designers or technicians. The firm is employee-owned, and the way CH2M Hill works, which is why I enjoy working there, is that it's based upon 13 of what we call business groups. So what that means is, inside the firm, we take in projects based on, for example, a water business or a transportation project or a government facility project, a power project, etc. The project management team in that group figure out what we have to do, then hand it off to the design arm to actually go ahead and design the facilities. So I sit in the design arm in Toronto as one of the architects. So when I say BIM, the exact definition of BIM is a building information model. When I pose the question, what is BIM to you? I'll get a response, Revit, Graphisoft, sometimes Triforma. I'll hear it's a model, it's expensive, it's different. For us, BIM is just a way of thinking. It's a mode of project delivery that's, in essence, it's different from the 2D drawing approach, it's different from the 2D CAD approach, it's different from a 3D model approach, but it's just a project delivery method. So throughout the course of this presentation, I won't talk about software because for me, software is the irrelevant portion of BIM. It's just a tool, just like when we were on the board drawing, we had pencils and used different pencils. When you were doing CAD, you used different line work. When you're doing BIM, you can use different pieces of software. So a lot of the examples that I will be using will be from the Bentley Triforma software, which is the software I use mostly internal to CH2M Hill. But throughout CH2M Hill, we've got Triforma and both Revit working simultaneously, doing what I'll be demonstrating and showing. What I'm going to cover is loosely this agenda, starting like, what is BIM, why do we use it? And then I'll talk about how to plan for BIM, both internal to your firm and conceptually with respect to how to plan for your project. How to manipulate BIM. And for me, that's the most critical thing, is what do you want to do with the BIM? Because if you don't know what you want to do with it, there's no point in trying to do something with it. And oftentimes, the complaints or the fear or the reservations with respect to a building information model is due to the fact that we want to jump and use a BIM, but we don't actually know what we want to do with it. And somebody once said to me, how do I know what I want to do with a BIM if I don't know what a BIM is? And that's a fair question. And my response is, well, when you do a design, what do you want to do? Well, I want to make a drawing, and I want to have contract documents to give to a contractor. I said, great, well, that's the first thing you want to do with your BIM. You can't go and use building information modeling if you can't produce what you normally would produce without a building information model. So you start from that fundamental premise, and we'll talk a little more about that. Then the use of BIM. So once you know how you want to manipulate, I'll show some examples of how we actually use it within some case studies and some examples of the work across CH2M Hill. Leading that into the examples. And then finally, the last bit I'll touch about the tools, because as I say, the tools are irrelevant. Obviously, you can't do a BIM without an appropriate tool, but I want to get across to this audience that BIM is a conceptual idea. The tools are how we actually bring our ideas into fruition. Now, the term interoperability, for those who aren't familiar with it, is how well each tool can talk to each other. So in the last many years, we've had and I'm sure many have heard Revit and Graphisoft and all these other tools that sort of can talk to each other, sort of cannot talk to each other, so that if you chose one, you get stuck in their stream of tools. Well, in the last 2 years, all softwares have been trying to say, well, if you choose ours, we will read somebody else's. So if you're using Graphisoft as architect, and you're trying to pull in Revit from your structural engineer, all the software firms have signed an agreement saying, you're using ours, but we will let you read theirs, so that we can actually have a project that has a meaningful bit. And I'll talk about that last. And then if there's time, there's about 140 slides here, 2.5 hours. If I breeze through these, I have an example of Navisworks where I'll actually drive through the model a bit and show you one of our smaller BIM models. If not, we'll see how it goes. So we'll start with what is BIM and why BIM? So this survey here, the AEC actually sent out a survey asking how many firms use 3D, and they got an overwhelming response of 98%. And that's an incredible thing. 98% create a 3D virtual model. 75% say they use 3D regularly. So they said, that's super, but how many of you do a multidiscipline 3D model? And that's where it's not just an architecture firm creating a 3D rendering, it's actually designing using every single discipline inside a model, 34%. So it's drastically lower. And then the last one, only 12% have what's called an integrated model and a project database, which is in essence what BIM is. You have stuff in your model and you have data associated to that stuff. Now, when we say database, it's not, it could be a physical, like an Access database, a SQL database, or just the databases that are contained within your CAD software. So if you look at CAD and say, well, CAD is a database, that's what this is entailing, because you're not just drawing a line, you're drawing a line that contains vector information from point to point, then you can attach a layer to it, and then you can attach more stuff to it. So as you get more complex into the world of 3D, you have a wall that has vector points for length, width, height, surface area, and volume, all contained within that wall. And then you attach more stuff to it. You want to say, well, that wall is concrete, or that wall is going to be concrete masonry unit, and all that is creating a robust database native to your CAD files. And feel free to just interrupt me with any questions as I'm going along. As BIM is used, there's conceptually, you need to understand when do we need information and what's the effect, what's the negative effect towards cost with respect to lack of information or informational changes. And that's what this graph is trying to show. When you're at the beginning of your project, surveying, design, even planning for construction, the relative cost of lack of information is far less than once you're into construction, doing as-built information, or even trying to manage the building and the systems. So we struggle internally with several engineers and architects saying, you guys have to understand that no, we can't do the last minute thing. We need to think about the project from the very beginning. We try to follow the AIA's 4-phase process, so project definition, schematic, detailed design, contract documents. Everybody seems to want to do work in contract documents right at the last second, and that really, really hurts BIM. And that's probably one of the fundamental differences in design. And what happens when you push stuff to the last minute, then you're doing RFIs, RFQs, change orders. Things are all happening during construction when the relative costs are much higher. So what exactly is multidiscipline BIM? Basically, we as architects will produce some kind of an architectural model using some tool, and we'll want to have each of the engineering disciplines, either combined or in isolation, create models as well. So every discipline has something, and at the end of the day, the multidiscipline BIM is a single combined model, a space that holds everybody else's information. So we can't work in isolation. We can't work architect here, engineer over here, other engineer over here. We're all working together in one single virtual space. And that's the critical difference. So when we're working in this mode, we've got vertical ducts, vertical columns, horizontal plenums. Everything has to work within each other. When things are touching each other, when things are interfering, we can identify them within the model. This portion of the presentation, this is something that we've created internal to CH2M Hill for our project managers to let them know, well, we'll use the term BIM, but what does BIM actually mean and why are we actually saying it? This is not BIM. This is beautiful, but it's not BIM, right? These are just 3D renderings, probably of models that were developed in isolation, possibly using something like Studio Max, just to give the impression of the building. If I wanted to drive into that building in the 3D model, there's probably nothing there. There might not be anything on the back of the model either, so it's just for rendering purposes. Effective in their intent, and that's something else where I'll say, know what you want your BIM to do. If I say, what do you want, and you say, well, I want a rendering. Well, you don't need a BIM for a rendering, you just need that for a rendering, right? BIM in its fundamental is you need geometry. Geometry carries the physical space, both length, width, height, surface area, volume. That's your geometry of every single component that will reside within your building. Plus your data. That's what creates your BIM. So your data, and this is a screenshot from MicroStation, but any of the software will have that, where you touch a component, and that component will give you all the information you want it to contain. So there's information by default, as I keep saying, length, width, height, surface area, volume. Then there's other information that we've actually built in this screen to define. So this example here is showing a mechanical condensing unit. Our mechanical engineers have stated that they want that information when they touch a condensing unit inside the model. So when we model those units, we have the ability to fill out that information at any time throughout the design or construction process, and that information be available on demand. And just to back up, I don't think I stated that in CH2M Hill we actually have all the engineering disciplines under one umbrella. So sometimes it makes BIM a little easier, sometimes it makes it even harder, but we'll talk more about how the structure of your model works. But that's why we're able to define stuff for the engineering disciplines. So this is a project I worked on about 4 years ago. It is a water treatment plant in Peel Region, the Lakeview Water Treatment Plant. And I like this drawing because it's just a drawing. It did its job, it's a section, but it doesn't do that. And that's the difference. This is the same section that's cut through that model, shown on that drawing. This shows the picture, for me, far more robustly than any section or plan can ever show. And when we deliver our contract documents, we deliver them kind of as a companion. And going back and forth, there's a lot of stuff happening over here that you just can't tell is happening in the plan, in section, but you can clearly see it in the model. Now here, if you say, well, how's this any different than those renderings I showed at the beginning? The difference is that they're both generated from the same model. You get your drawings, you can get images on demand at any time, at any point throughout the project. So to create this, it wasn't a special visualization effort. It was, I don't want to say just click the button, because you got to set up your materials and your lighting and make it look good. But it was much closer to click the button than giving your plans to a visualizer and saying, please create me a model. So the model, the building information model, is the center of your BIM universe. Everything will happen, everything will go into the model and everything will come out of the model. You have to define and know what do you want that model to do. And I keep stressing that because you can model to the greatest granular detail, or you can model just enough. And you have to know in your firm what just enough is. And part of the role that I carry at CH2M Hill is to actually determine what is just enough. So a recent project, or a current one I'm still on, is the Olympics in London. And the concept there is we want all the venues and facilities to be developed with the BIM so that the Olympic Committee can have a complete bill of materials at game time so that they can decommission and know what they're decommissioning for recycling purposes and reuse purposes. So we've sat down with all of the design partners in the UK who are working on the Olympics, and we've said to them, this is what the IOC has mandated us to know, that we need to know concrete volumes, we need to know steel lengths, and we need to know exterior cladding areas. Those were the three most critical items so that we could decommission those facilities come the end of the games in 2012, and they could reuse and recycle most of that material. Other firms or other times, you might want to have the most granular of detail because you need specific renderings. You want to have animated walkthroughs through certain spaces. Other times, and I've been on projects where I've been told, we just want to know volume of concrete, that's all. So then we sit back and say, well, the model is really just to deliver my drawings. So I need to put enough detail in the model that when I cut my section, that section line actually looks right. And I'll honestly say maybe 60–70% of our projects in CH2M Hill, that's the only point. It's just I need to get my plans and my sections out of my model. But 30% of the time there's far more required in the model, and that's what has to be defined. So with a model, now you could take that model and you can suck it into analytical tools. So if you're looking to become lead, get the project lead certified, you can take the model and pull it into an energy analysis or a heat analysis tool and actually prove several of the credit requirements. And there's specific tools that the lead credits actually say, go and do this kind of model. Both Bentley, Graphisoft, and Autodesk have made their model interoperable with those analytical tools. So they've actually sat and worked with the guys at USGBC and CAGBC to make sure that the information that they're providing to the analytical tools will meet the credits defined by LEED. And as I've said, drawings and schedules. This is by far the biggest thing that we get out of a BIM. And the benefit there, and what I've always found is, when we're on a small project, and I've done 5 meter by 5 meter pump houses, I've done little things like that, where a project manager will say to me, don't bother with a model, just draw it up. But for me, to draw a plan, draw a section, draw an elevation, I'm drawing the same thing over and over and over again. If I model that wall is there for me in plan, section, elevation, details, anything I want it to be. That's the benefit here. With the use of BIM, if you clearly define what your BIM is, you get your schedules out of your model as well. So there, when I model my door, I have a predefined cell that I place in the model. It automatically carries all that information that I want to have in my door schedule. So when I place my door, I'm able to fill out 5 or 6 things, all the hardware I need. There's my door schedule straight out of the model. And I'll show a couple examples of that as well. As I showed visualization, click of the button to generate, a little bit of setup to create materials and make sure you have your right brick, your right precast, your right whatever. It is click of a button because it's set up once and it can be done at any time throughout the project. The model grows, the next time you click visualize it, it becomes far more robust. You can have direct linkages to specifications. We're really weak on this in CH2M Hill. Like, this is one of the big selling points for in like the worldwide industry is, oh, you can link to your specs. And I think that comes probably far more with design build projects where you are the designer and the builder and you're carrying it through and you own that model right to the very end. You're able to click on a component and hyperlink to a centralized location for your specifications. Design review. There's tools to do this. Probably the most famous one, well, that changes every day, but I think currently the most famous one is Navisworks, because Navisworks can read any and all platforms, Bentley, Autodesk, Graphisoft, and anything else that there might be, suck them all into one space and let you walk and drive through the model. And if there's time at the very end, I'd like to demo a bit of that. There's other ones out there, some native to, there's ones native to Bentley, there's some native to Oracle, there's some with Intergraph. All do the same kind of concept. You grab everybody's models from all your disciplines, all your subs, suck them into one spot and drive. And you're able to visually see what's going on, get a visual understanding of the model, and you're the user input. It's like a first-person gamer for those who do that. Clash detection. Once you have it in that design review space, you can do two types of clash detection, hard and soft. A hard clash detection is software, tell me everything that's touching. So we've got a duct through a beam, really bad clash, especially if it's in the bottom of the beam. You've got a column sitting on a slab. Maybe that's not an interference, but the software just grabs everything and says, show me everything that's touching. And you as the viewer can determine, you know what, that column is supposed to sit on that slab. That's not an interference, but that duct should not be going through that beam. That's an interference. Grab the structural engineer and the mechanical engineer and say, you guys have to fix this. And their thing might say, well, we were modeling in our own computer in isolation, it looks perfect. Yeah, but when you put the picture together, that's the whole point of the clash detection. Then you've got the soft clashes. So there you have, and in our treatment plants, this happens a lot, where you've got an electrical panel sitting in the middle of a corridor. Great, so it's not a physical interference, but you can visually see, well, yeah, there's severe code issues with having something block my exit. So that kind of thing, the software will never pick that up. We've tried writing scripts where if we have a stairwell and you need certain clearances for barrier-free, we try to create like zones of nothing can go in here, but that works sort of and sort of doesn't. So for soft interferences, visually is probably the best mode to go, and that's where the design review tool comes in. Your data going to the cost estimators. This is a huge one for our design build projects, where what we found is ductwork, concrete, and steel are probably the biggest cost from a building perspective, that in the past the CH Tool and Hill estimators have had troubles or have been the most inaccurate because of the inability to understand what's happening in the plans and the sections. So we're able to give them direct lists and reports on how much volume there is and how much pounds of steel, right down to the steel size and the pounds and the type of concrete. It's a slab on grade, an elevated slab, so they can add multipliers with respect to the types of reinforcing that'll be put in there or the types of associated costs for formwork. And finally, scheduling. You can schedule anything, absolutely anything. The question is, what do you want to schedule? And that goes back to know what you want from your BIM. So when we started, we know nothing about BIM, and that's fine. So what do you want to do with the BIM? Well, I want my drawings. Great, we have drawings set up there. We want my schedules. You have your schedule set up there. Scheduling. If you're in a design build project and the contractor says, well, you know what, we want to be able to actually simulate how construction will work. Present it to the bidders, show them how we're going to do it. Well, you have to know that going into the model. And I'll use an example later, but if you just think about how you pour a concrete slab, for example, if you've got a mammoth slab, it won't go in one pour. So I can't model it as one mammoth slab. And it's that kind of thinking, and we'll sit our modelers down and say, think of how this will be built. And their response, I have no clue how it's going to be built. It's going to be a wall going from here way up to there. Well, yeah, but will it be built that way? If you don't know, ask your structural engineer, ask your architect. Find the information before you go put that model in the paper. And this is probably the hardest thing, is that we're not just drawing lines. We're actually drawing meaningful information. And when the drawers don't know that information, that's where a lot of the stress comes into play. And we always go back to, well, communicate. Ask the question. Somebody has an answer all the time. Beyond design, the model can be used for so much during construction, procurement, fabrication, and constructability review. When we're doing our design build projects, specifically for water treatment plants, we'll go off and procure the piping specifically derived from our model. So we'll get pipe lengths and valves and fittings and all those wonderful things will come directly from the model. Then we'll use the model to determine how much building material we need. So they'll take the actual structural steel and get a list by component, by steel type. So these types of beams, we have these many. These types of columns, these many. And then we'll give them volume and surface areas of brick, concrete, precast panels, all of that, so that they have an idea of how much they need, but they won't actually procure those from the model. And then fabrication, oftentimes we'll send our steel structures through fabrication models where the fabricators, instead of starting from scratch, they'll take our model, pull it into their system, and manipulate it from there. I almost laughed at them once, and this was about 6 years ago, when a fabricator said, we took your 2D files and we generated our own model. And then I sat back and I said, but our 2D files came from our 3D model. So we went from 3D, we dumped it down to a piece of paper, and then they smarted it back up to a 3D model. That's not a good word, I'm sorry. And I sat back and I said, well, why are we doing this? Why are we going smart, dumb, smart, as opposed to just take the model and do what you need to do, because that's what you want to do anyway. And then constructability review. This has been huge for us. On any procurement model, design build, design bid, whatever we're doing, when we're going into sites, we have to respond to RFQs, respond to RFIs, we might generate some RFQs. The model becomes a critical piece to sit down with the contractor and say, well, this is what we meant to do, so this is how you misinterpreted the drawings, in our opinion. They don't think they misinterpreted. And this is what we're now proposing to do. And it's all done via the model before, after. And then we can go and generate the plans and the drawings as required. But the critical thing is that we're being asked now by contractors who will see the model during bids to say, put the model on site for us. We want to see this. We want the model. We want to drive through. We want to know how to build this thing you want us to build. So that brings us to the concept of life cycle data flow. And all that means is that the model will live from the day you start your pre-design to the day that building's decommissioned. Now, there's a lot of legal ramifications with respect to liability that, I'll be talking with the OAA over and over. I always send them messages saying, if I want to stamp my model, how do I do that? I don't get an answer yet. And if I want to take my model complete with all of my information and say, here, contractor, have fun. A lot of issues around that. So from a legal perspective, we have to figure out how best to make this happen so that we don't all lose our licenses. In CH2M Hill, we're going through the same concepts. Our lawyers are sitting down saying, well, you Brent, are talking about this model thing. Nowhere in our legal documentation and contracts does it talk about this model thing. So I'm pushing them to figure out, well, what do we have to do so that I can come in during design and do all this that I want to do? What's the legal ramification of me giving a bill of quantities and a bill of material to the bidders? I don't know, right? But the concept is, if I tell the bidders there's 30,000 cubic meters of concrete, there's 30,000 cubic meters. They should all, in theory, bid on 30,000. They might add contingencies or whatever, but what we found is when we put out information like that, it actually just narrows those bids to make them more meaningful, so we can actually weed through, well, what are the differences and why are they becoming different? But I, as architect, am saying there's a certain volume of material or area of material. What does that actually mean from a liability perspective? But the concept is the model's there. During design, I can do all the stuff I described. Then I want to come and I want to throw it over to the contractor. I want the contractor to take my model and do stuff with it. Now, we've sat back and argued, okay, if I have an archive of my model at its state at the point of turnover, I think I should be covered. But that's a whole other discussion. The model is there during construction. The contractor can do procurement from it. The contractor can generate his phasing, he can do his construction scheduling. He can see how this thing is meant to be built and why. What were we talking about? He can look at our set of plans and say, yeah, that all looks good, but what do they actually mean? He can find out what he cannot see in the plans here in the model. And then from the model, he can sit back and say, well, okay, here are the plans, here are the sections, but there's not enough for me to give to the precast sub. Let me go to the model and give pieces of the model or cut other things so I can create my package from contractor to sub. And that's all based on the data provided by us as designer. And finally, the as-built information. And this is I don't know how good of an experience you all have with as-built data, but being just drawings, but our as-built information sometimes is awful. We want to have an as-built model, and as of right now today, we're starting a new project, that Lakeview Water Treatment Plant, we're starting the phase 2 of it. Well, when that building that I showed you was built, there were modification here and there, and now we're doing a whole new add-on to that building. Well, lo and behold, the steel framing for the superstructure shifted and changed a little bit. And we didn't know that because the model wasn't up to date. So now we're going onto site, field measuring what the contractor didn't put into the as-built drawings so that we can now design the extension of that building. This is a huge thing. And if you know that you're not going to do anything more to that project, fine, but somebody else may. And that's the value of the information to the client. And this goes for 2D or 3D, it doesn't really matter. You want robust as-built information. From our perspective, the BIM just helps to facilitate it. When construction's over, there'll be some form of operation and maintenance for the building. Now buildings, there's so many different classifications of buildings. Some operations are just, how do I run my HVAC system, to how do I run a specific process within the building, to how do I just maintain the shell of the building. All that information it's dealt with in many different ways. We usually provide operations manuals to our clients depending on what business group we reside in. So in our water business group, the operations manuals are huge because it has to say not only how does the building work, but how does all the pumps and the valves work. In our government facilities, like we do a Department of Defense buildings in the States. I hope that's not a fire alarm. Okay. And everybody's jumping up, so let's just continue. All right.
I don't know. I think it's fire.
Should I continue or? Okay. You guys are the boss.
So should we check at the door?
That's a good point. If it's a 2-stage, we'll wait for a second. What was it? Yeah. So we do Department of Defense buildings, and one was an aircraft hangar, and there was nothing that had to run.
Okay.
Is that the second stage? Okay, so until the announcement comes, the main part of that hangar was to actually define how do those hangar doors work. And then the rest was how does the facility maintain itself. So the manuals will change, but the important thing is that the manuals, specific information from those manuals can be derived directly from the model. And then at the end of the day, what's going to happen to that building? So I developed this diagram in London. And the reason for it was the Olympics, because the model at the end of the day, once we went through all of that, operations and maintenance was we're going to run the games. Then when the games ended, well, what are we going to do with this model at the end of the day? They're going to decommission half of the venues. Olympic Stadium, for example, is going to go from 70,000 seats.
Ladies and gentlemen, this is the manager on duty. An alarm situation has been reported on the main floor of the North Tower. Please stand by for further announcements as we are investigating the source of the alarm. If you wish to leave the building, please use the nearest fire exit and proceed to street level.
And it is funny that maximum occupancy is 45. Yeah. Attendees are 57. Anyway, I just wanted to point that out. So, Olympic Stadium is going to go from 70,000 down to 30,000 seats.
Ladies and gentlemen, this is the manager on duty. An alarm situation has been reported in the North
This has got to be
Tower.
the first time this has
Please
happened
stand
during one of
by
my
for further
presentations.
announcements as we are investigating the source of the alarm. If you wish to leave the building, please use the nearest fire exit and proceed to street level.
So they're going to use the model to determine how much of the stadium is going to have to come down. And once they rip off all of that material to be decommissioned, how much material is it? Where can it go? And what can we use it for? Now that's a massive scale program. But you can, BIM is completely scalable, and that's the point of showing this, is that as long as you know what you want to do with your BIM, these concepts apply from the Olympic Park right down to your house, and everything in between. So with that, the scalability of BIM, we have what's called a degree of
Ladies
BIM.
and gentlemen, this is the manager on duty. An alarm situation has reported in the North Tower. Please stand by for further announcements as we are investigating the source of the alarm. If you wish to leave the building, please use the nearest fire exit and proceed to street level.
So this was a selling point to our design managers and project managers. So we'll use the word BIM, and they'll all get scared. Oh, you're going to kill our project's budget. But no, we're not. We're going to use BIM for a purpose, and what we show here are a couple of purposes. So oftentimes we do the space charrettes. So how do we want the building to lay out? And an architect might give us the sketch. We might have a plan sketched by a client or by whomever, and we start laying spaces on top of the plan.
The fire department is on scene. Per local fire regulation codes, our fire alarm system will remain active and the bells will continue to ring until the source of the alarm has been determined. Once again, if you wish to leave the building, please use the nearest fire exit and proceed to street level.
So this is BIM in its smallest concept. So I don't even have a model right now, but I just have spaces. So spaces can be applied through any of the BIM tools. And all that is I'm blocking off an area, but I'm adding data. So when I put in that red square, I tell it what is the red square. So what's the room name? It'll automatically tell me what's the area, and I can fill out a little more particulars of it. And certain softwares allow you to do 3D spaces too. So I could actually enter a space.
Ladies and gentlemen, the fire department has instructed the hotel to reset the fire system. There is no further action required on your part. Thank you, and we apologize for the inconvenience.
And that means no further announcements. That's good. So, when I'm drawing these spaces, I can actually set some spatial heights. So just by looking over a sketch, tracing over, we're able to actually get the fundamental premise of what the model could end up being. And I have a diagram, a little video that'll show that after.
Ladies and gentlemen, this is the manager on duty. The fire department has instructed the hotel to reset the fire system, and there are no further actions required on your part. We do apologize for any inconvenience. Thank you.
So once we've done the spatial arrangements, we can jump up to level 2, where we can just put some basic walls and give a basic idea of the space movement on top of that sketch that was initially presented. So level 2, we say we just want to define the space, we want to define the circulation, and start the premise of what a model could end up being. Then at level 3, we want to have the skin, maybe just an architectural model, just enough for 1 or 2 disciplines to get the information they want out of it. So this is where I showed, okay, multidiscipline BIM, everybody working together. But you might get a sub-consultant who says, I'm not doing BIM. I don't know how to model, I don't know how to use that software you're talking about, forget it, you'll get my plans. That's okay. You can still use BIM knowing going in the limitations of what you're going to receive, you can still get something out of it. And then my favorite, of course, is level 4 where absolutely everything is in there, right? Every discipline in the BIM, or as many disciplines as possible inside your model. One spot, you see everything, you generate your full contract document schedules and everything else you could think of from that one model. So I'll always ask, what's the benefit of BIM? Why do I want to do it? And I will list benefits, blah, blah. But here are the ones that seem to resonate the most with our project managers and the ones that end up on our proposals and stuff. The interference checking to reduce change orders. That's an interesting one, and we actually had a project that I'm going to case study after where we were brought in just to do a BIM after the design, and we found, I think it was 115 interferences that the client said would have saved me, I think he quoted $7 million of construction change order. So it's that kind of thing where you think, you know, is that a real valid statement? But yeah, if we catch the duct in the beam during design, That's better than catching it during construction when the costs of change are much higher. Oops, I'm sorry. Model precision means predictable outcomes. And that one, when we're all working in the same space and we all know the intricate relationships between architecture, structural, building mechanical, electrical, and any other discipline that's there is a huge precision there, meaning that you will know what's going to happen. It might not be 100% accurate, but it has to be far more accurate than when we were all drawing on 2D CAD drawings. Why do I keep doing that? Early planning means efficient material use and less waste. If you know what's going to go in that model, you know what's going to go in that building, you can help to guide the contractors to understand this is all the material that we're going to have. They can help plan for it, accurately order stuff, be more sustainable, and we can understand where the material is coming from, how much we're using, how much waste there is, and we can mitigate the waste. Seeing is understanding, and that one's profound for me as well. You could see your design in real time, in the 3D world. You can use it as a companion for your contract documents, and you can actually understand. Anybody can understand. You can sit in front of your client who doesn't know how to read a plan and say, this is your building, and the client will say, I get it. Versus, you show me that in the plan again, well, let me see that elevation, I don't get it, it's all confusing. And I've had that several times. How do you plan for this, right? I just threw a lot of stuff at you. I guess, first of all, any questions? Quite a few? You want to throw one at me?
What's the cost of this thing? What's the deductibility of that? Who pays the cost of that? Is it the client? What's the overhead on that versus your normal cost? I'm assuming they come down.
Yeah. Do you want me to answer?
No, just.
Okay. We'll do. Because let me touch on the cost of it is interesting because.
What was the question again? I didn't get the question.
If you're the client, who bears the cost of this? What's the cost overhead over the normal fees the OAA would charge?
Yeah.
How acceptable is it within the industry? How updatable is it? If I have it at the Parliament precinct 10 years down the road, can I still use this? Yeah.
Yeah.
I mean, you know, just.
Yeah. No. The updated. Yeah. I want to touch on the cost one because that's good. We when we started, there was a learning curve. Okay, and that goes without saying. The first time you do this, it'll cost you more of your time to develop this the first time. But I can swear by that it costs me less time to develop a design now than if I had to do it in 2D. So what we did is we would actually bear a bit of we took a bit of that cost the first couple of times, but now we're actually underrunning our cost per sheet. So I don't work by cost per sheet, but our managers do. So architecturally, I think they plan 50 hours a sheet on a project. And the first time we did BIM, I think we ran at 65. Currently, when I do my projects now, I run at 30. It's almost, well, yeah, it's exactly half of what I would have in a 2D. And the reason for that is I'm spending far less time actually trying to figure out, well, what's happening between myself and the other disciplines, and what's happening between myself and the stakeholders and the civil, and how does this all work, because it's all there and I can see it. And I'm spending far less time doing CAD, right? It's coming out. And if you conceptually think, if I model my wall, I'll go back to that, my wall, length, width, height, right? I can, from my model, get plan, section, elevation because the wall is there. Now, obviously, if my model is good, my output is good. If my model is bad, my output is bad. But it saves me so much time to have to, even from a CAD perspective, to just lay out these files because it all comes directly from the model. And the updatability, let me touch on that one too. Because I like that one, because I get people saying, I don't want a model because it's too hard to fix. And I love that one, because I sit back and I say, well, what do you mean by fix? And they go, well, you know, when an engineer says to me, and I don't want to pick on structural engineers, but I get this a lot. I'm going to model the slab. How thick is my slab? Oh, around 500. Okay, what do you mean around? Well, you know, the engineer said he doesn't have time to calculate it, so he said do it as 500. I said, okay, what if it turns into 700? Well, I'll just change it, I guess. And then the question is, well, do I change it in the drawings? Do I change it in my model? And then the question is, but if I change it in my model, it'll start interfering with all the dots. Like, exactly. That's the whole point. That's why you want to change it in the model. So to actually change components, it's just a tool of the software. You can change it, you just update your drawings, and it appears. The consequence of that, and this is where I always say, look, you guys are used to, go change it in your plan, that's it, it looks perfect. But no, you have to change it in the model because you're having detrimental effects to everybody else on the project. That's where I get the, it's too expensive to work in 3D because it's too expensive to change. No, because the change has consequences and it's visual, it's conceivable right away versus in construction where all of a sudden nothing fits. And then to use the use of BIM downstream, we're reusing models that so this plant expansion that we're doing now to our model 8 years ago, we're using that same model as the base foundation. So software will keep getting better and better, but the usability of these models, they'll just be able to progress with the time, if that makes sense. So it's there, it's the foundation. And even though we used a version of the software that's 5 versions ago, it's still wholly applicable to what we're doing now, even with updated CAD standards and updated ways of thinking, a clearer definition of BIM. We were still able to use what we had before. Questions? How do you plan for BIM? So this leads into again to that question. We have a mode of working where, and I call this the siloed effect. We're all doing our own thing, and at the end of the day, we're going to produce this construction set, and I like to say hope they all talk well with each other. In theory, there was a lot of collaboration and coordination, and in theory, your construction sets should be in sync with each other. But there's no guarantee, because we are, no matter how much we communicate, we're always working in our own silo, because we're not integrated into one space. So this is the concept of the 3D model. We are all in one space. We may have pieces of that model in our own offices, but those pieces come together as a whole. And from that whole, we're able to derive any one of these items. Contract documents being just a small piece of what can come out of the model. I made this slide 4 years ago, and I still struggle with implementing it, because for me, this is a fundamental. When you have to make changes to your design, and we all have to make changes to our design, it's far easier to make a change when you're in the concept phase than when you're at the contract document phase, or what we call services during construction. If you want to make changes during construction, they're going to have far greater ramifications than when you're defining your project. The cost impact of the changes is the opposite curve. Conceptually, if I want to make a change during project definition, the cost impact might be I need to update my space plan, I need to update my massing model. If I want to make a change during SDC, well, who knows what might happen. The contractor might have to tear down, rebuild, reorder, extras, change orders, who knows. The design effort from the traditional mode has been, we work through the first couple of phases, and the bulk of the effort occurs during these contract documents. And what we promote and push is we've got to take that hump and push it back in the project, where the ease of change is easier and the cost of the change is less. Now, if you ask, well, what's the cost during contract documents? It pales in comparison to the cost during construction, but still, once you've gotten so far down the road to turn around and say, well, now I just want to do something different, it's just much harder to implement. And if you follow the 4-phase process with the AIA, they promote this where we've got schematic, project definition, schematic design. Let's use those phases, get sign-off from our clients, and then push back when unexpected changes occur. Ask for the extras, engage in that dialogue, if it's politically correct for the client relationship. Oftentimes we have to eat it up inside because the answer from our project manager is, well, we want another job from this client. So what the client told you to change it, just change it. So we do it. But conceptually, we push to have this model. Putting that in practice is probably one of the more difficult things. So BIM is virtual, and you have a set of teams, a set of disciplines. So let's just say you have them all together. How do you make them talk? Conceptually, they're all working from a specific project building information model, a central database of some sort. And each discipline needs a piece of that model. Right? So I'm the architect, I'm working on architectural. Structural is going to be working on the foundations, maybe the concrete slab, some upper concrete work. I'm going to take my information and I'm going to send it back to the BIM and say, I just updated all this stuff. Here it is, work around it. We're all working in one central location. And then it's going to be a push-pull. I'm going to see what's in the BIM. I'm going to pull out my data, do stuff to it, put my data back and say, see what I did. Then I'll say, oh, structural changed. Let me change, put it back. This works great in one office. Right? So in our Toronto office, we can do this because every discipline is under one roof, under one local area network, and we're good. So when you have separate offices, trying to apply this concept, well, it's a little more difficult because you're a victim to network access by each office, you're victim to wide area network speeds, you're victim to internet connections. This is not the most optimal approach. One person will have a quicker connection, another person will have a much slower connection, and those connections are not guaranteed. One day your connection will be slower, certain times in the day it'll be slower. And we come across this in CH Stone Hill when we're working throughout multiple offices. So if I have the central BIM location in Toronto and we want our office on the West Coast to work on it, it just can't facilitate that data transfer back and forth continually all day. So we have what we call a federated database. And that concept there is we all have a piece to the BIM and we'll just take it like a piece of the puzzle. And I'll take it into my own office and I hold my piece of the building information model. This works great for architects with subs, for multi-office firms where work is being distributed across wide area networks. At certain times, I'll be given updated data. So a structural engineer says, you know what, I completely updated the foundation model, here it is everybody else, and sends it to everybody else. So that concept there is, whenever there's information to be updated, it's sent across to each and everybody else's area so that they can piece the puzzle together. We have instances of that puzzle that allow us to work in the virtual whole. So once the design is completed, or at certain phases where I want to pull in a design review and I want to walk through the model, I can come and grab all your pieces of the puzzle, put it in one spot, and drive the model. It's the most current. With this way, you're able to work whether you're within one office or really in any combination of offices. So in an office, multiple offices, certain disciplines combined in certain offices, any way will work because you're actually working within single local area networks and throwing information across from office to office. So these are the two modes. I guess the question now would be, so what? What are you telling me? Do I do the one on the left or the one on the right, right? And at the end of the day, I'm probably telling you both, but this is where you got to understand, what do I want from my BIM? So if I'm an architectural practice, sole proprietor, and I want to create a BIM for the sole purpose of creating my architectural drawings, I'd probably go centralized. It's going to be in my office. I'm going to build this model. I'm going to make my drawings, and do a couple other things from my BIM. If I want to have a structural engineer, and he agrees to do BIM, and maybe a mechanical engineer, you'd probably want to use the federated one because they're not all in your office. So there's no way you guys are you don't want to set up this infrastructure to slowly transfer data back and forth. You want to use a federated where I, the architect, will say, give me your information when you update it. And it's sent to me, and we're all modeling within the same virtual space, just in two spots. And then when the stuff comes together, they're all a whole. So then it's like, well, how do I ramp up to conceptually even start to do this? And I'll tell you some of the stuff that we've done. first is know the difference. I'm not going to do 2D, I'm going to do BIM. So conceptually in my head, I can't think the way I thought when I would create a 2D plan or a 2D section. When you design, you're actually designing in 3D, which I think we all do by default, right? When we conceptually draw something in a plan, in our heads we're thinking, yeah, that's going to be so high in elevation and it'll have this. We do that. The BIM is just saying do it. Like really do it now, as opposed to draw your plan and think about it and then you go draw your section later. Pick the team. Don't do a BIM if you have no one who can model. Right? The two will kind of go hand in hand. If you have somebody who's adept to the tool, somebody who enjoys 3D modeling, maybe someone who does your visualizations, engage them and say, well, do you think you'd be capable of doing this? And explain your ideas on, this is what we kind of want to do, can you do it? And get the right team to do that. And train the people and coach the team. So I'll just go one by one on what we did internally. 2D versus 3D. And this is a Packard planting plant in North Carolina. And here, it was just the difference where the plan of that roof didn't give the impression of what we wanted versus the model. So the two worked hand in hand. But the critical thing was the model drove the design of the roof. The plan was the output. And that's the difference versus the plan is what I'm doing, and here go give me a visualization after the fact. So we actually designed this in the 3D world, building the superstructure the way we wanted it to, and the plan just came after. Pick your team. So this is where, left or right, what are you telling me to do? If you know who your team is, that'll really drive you to this. If everybody's inside your office, it'll drive you to the left. If everybody is outside of your office, or even one party is outside of your office, it'll drive you to the right. Train your people. So in CH12 Hill, we have what's called an e-learning library. And obviously, not everybody will have this at their fingertips, but what we discovered was, we would phone the software developers and say, come on in, give our staff a 2-3 day training session, blitz them on your software, and then away they go to work. Well, that would never work that way. So they'd come in, we'd get 5 days on how to use Revit, or 3 days on how to use Triforma. Go back to your desk and say, well, what did I learn on day one and hour one? I can't remember. And we'd struggle and stumble through applying it onto the project. So with the use of Camtasia, which is just a screen capture video tool, we just said, well, when you know how to do something, just hit record. All right? So something as fundamental in our software as how do you draw a line. So your software is open, you click the button for line, and you click point, point. Seems so fundamental, but we said, well, let's make a video on that. So when we make new hires, we throw them to this website and say, just start looking at the videos. Do line, and open up the software and draw a line. Do circle, draw a circle. And we fundamentally go through it that way. So once they've got the 2D fundamentals of the software, we can throw them into the 3D. Okay, so draw a wall. Well, it's kind of like draw a line, only you have to input your width and height. So then click the button, width, height, point, point. And I'm making it sound so like easy because, in essence, if you have the infrastructure, it could be that easy, right? The help menus that come with these tools, they're okay. They kind of say it, but you kind of gotta find it, read it. They don't really have the video type tutorials. So pushing our users into these, I'll just play this one. I wouldn't need the volume. This video here, all of our videos are less than 2 minutes. And the video here is, well, how do I cut a hole in the wall? So we show, you could try to use that tool, but what this does is it makes your form into a dumb solid. We said we don't want you to do that because we want to keep what we call features in MicroStation, because that lets you recognize still length, width, height, surface area, volume. And then we just so click, click, boom, done. You cut a hole through a wall. And some videos are only like 20 seconds long. I think the first one we made was, how do I open the software? Start, program files. It's as fundamental as that, because when you come and hire somebody, they won't know. And we found in our Toronto office, we're more Bentley based, everyone we hire comes from has Autodesk experience. So when we hire our guys, if we don't have this to throw at them, somebody has to sit down for days on end to show them just fundamentally how do you open the software. And we have these set up for both MicroStation and Revit, so to cover any of our offices that we have across CH2M Hill. And we found that regardless of what we're trying to train them on, if we could just visually show, this is how you do it, it gets picked up, right? Now the learning curve behind this, normally we bring somebody in and we give them roughly a week. So the first day, because it's like there's all the corporate stuff, so HR grabs them and does whatever they have to do. So for the next 4 days, we put them in front of here and we just say, do this. Read a video, watch a video, use the tool. And he does this back and forth for about 4 days, and then I throw small things at them. And then all of a sudden, I have a new hire now who came to me yesterday. He's only been with us a week and a half, said, Brent, how did I put the door number on that door again so I can generate the schedule? And I said, oh my God, okay. So I went and I sat with him and I showed him, if I go back, we have this course here called Data Group System, which is MicroStation's term for your BIM system. So I brought him there and I said, well, just have a look at that. This will show you how to make sure there's data on your door, and this video will show you how to generate the schedule. And I walked away. So I think he did that today. But that's the thing, we all don't have time to sit down and say, please learn it and I'm going to hold your hand while you learn it, and we don't have time to, or we don't want to incur the expenses of getting the software trainers over, because their expense is huge. Now, to set this up, I'd encourage, if you have someone who knows how to use the tool, make them press record. So the premise behind this was, I don't need 3 weeks to develop the videos, I just need Camtasia. And then as I was modeling, I'd say, okay, well, what am I doing from day one to the end? So we did videos on our spaces, then we did videos on our walls, and each time we entered, we did a function, we just hit the record button, and then we could add sound or anything later. So when you look at your team, you're going to take this designer or engineer or architect, whoever it is that's going to be on the team, and you're going to direct them to certain training videos. And each and every one of these videos, as I said, we've got some as simple as, how do I open, or how do I grab a tool frame. Oop, that didn't stay up there. Sorry, try that again. So we send them to a video, and this is